Hello guys. So in this video we are going to discuss the solution of the problem split array largest sum. So let us look at the problem statement. So the problem statement says that we are given an array of n elements. So an array is given to us of n elements and a number k is given to us. Split the given array into k subarrays. So the array we need to split into k subarrays such that the maximum subarray sum available out of k subarrays formed is minimum possible. Find that possible subarray sum. So let me explain the problem statement. So what the problem statement says is basically, so let us say an array is given to us. So let us say an array is given to us and it contains elements 1, 2, 3, 4. N is equals to 4 and k given to us is 3. Okay. So what the problem says is that we have to divide the array into k subarrays. Okay. So k equals to 3. So we need to divide this array into 3 subarrays. Now there are multiple ways by which we will be able to divide the array into 3 subarrays. So let us look at various ways by which I can divide this array into 3 subarrays. So one way would be, subarray 1 will be basically the first subarray contains just one element. The second subarray contains one element and the third one contains the remaining two elements. Okay. Another way would be basically this, right? And one other way by which we will be able to divide this subarray is basically this contains 1, 2, 3 and 4. Okay. So what problem says is basically first we have to divide the array into k subarrays. So now we know that there are multiple ways by which I'll be able to divide an array into k subarrays. Of those various ways, what we need to do is that we need to compute the sum of individual subarrays. So for instance here this particular subarray, the sum of elements is 1, right? Here the sum of element is 2. Here it is 7, right? Here it is 3, 3 and 4. Okay. Here it is 1, 5 and 4. So once we have computed the sum of individual subarrays, what we need to do is basically we need to find the maximum of these sums. So for instance in subarray A, subarray 1, the maximum value is 7. So here it is 7 for this combination. Similarly for the second combination the maximum value is 4. So 4, and for the third combination the maximum value is 5. So this 5. And what we need to do is basically of these 3 values which we obtain in this particular case, by the way, for n equals to something else and k equals to something else, these combinations will vary, the number of subarrays will vary, the numbers of ways I'll be able to partition this array will vary, and accordingly the answer will differ. But for this particular case, once we have these 7, 4 and 5 with us, I need to find the minimum among this. So the minimum is basically what? The minimum is this particular element. Okay. And this is what I need to return. So that's about the problem statement. I hope we are able to understand the problem statement. Now once we have understood the problem statement, let us look at the solution. So let us first look at the brute force solution. Brute force solution. So the brute force solution is pretty simple. What we need to do is basically so for instance in this particular case where n is equals to 4 and k equals to 3, I have first generated all the these SA1, subarray 1, subarray 2 and subarray 3, all the various ways via which I'll be able to partition the array into k subarrays, first I have generated that, right? So in the brute force solution also we are going to do the same thing. First, generate all possible ways via which the array and what is the array? The name of the array is arr, by which the array can be divided into k subarrays, right? So first we are going to generate all those ways by which I'll be able to do it. Now, for all the subarrays, compute sum of the subarray and find the minimum value, right? So in a sense, what we need to do is basically first we will generate all these subarrays, subarray 1, subarray 2 and subarray 3. Once we have generated all these subarrays, we are going to compute the sum of all these subarrays. So for instance 1, 2, 7, 3, 3, 4 and so on. Once we have computed the sum, so for first condition I'm going to compute the maximum, which is 4. For second condition I'm going to compute the maximum, which is 4. And for the third condition I'm going to compute the maximum, which is 5. Once I have these values with me, I'm going to compute the minimum of these values, which is 4 in this particular case. Okay, so that's the brute force solution. Now let us look at the optimal solution for the problem. Optimal solution. So the optimal solution, in order to understand the optimal solution, we need to understand one concept, which is basically so our answer, right? So if you see, this was our answer. So our answer will belong to some range, right? So let me call it as answer. So our answer will lie in some range, right? So will lie from some range, minimum to maximum. And the first concept deals with what is this minimum range and what is this maximum range. Okay, so let us try to understand this. So in our example, the array consists of element 1, 2, 3 and 4. N is equals to 4 and k is equals to 3. Okay, so we need to partition the array of length 4 into 3 subarrays. Now the maximum, let us see the maximum sum which is possible here will be basically the sum of all the elements of the array, right? That is the maximum sum we can have. The maximum will be equals to sum of all elements of the array. So in this particular case, this is equals to 1 plus 2 plus 3 plus 4, which is equals to 10, right? So it is not possible to exceed 10, right? So for our example, the maximum will be 10, right? I hope how it is 10 is clear from this explanation. Now let us see what is the minimum, right? So if you want to understand the minimum, so the minimum is basically is equals to the max of the array. Okay, so in this particular case, the maximum of array is 4. So the minimum value will be 4. So we understand that our answer will be basically in the range from minimum to maximum. And what will be the values of minimum and maximum? Well, the minimum is basically max of the array and the maximum will be the sum of the arrays. Okay, so our answer will be somewhere somewhere here, right, in this range. So in our case, the range is basically 4 to 10. So somewhere between 4 to 10 lies our answer. So what we are going to do is basically we are going to use binary search over here, since like we can assume it to be a sorted array, and we know that one of this element is our answer, right? One of this element is our answer. So which is our answer? What we can do is basically we can do a binary search. So what we are going to do is that basically we are going to come to the first mid, which is 7, and we are going to check if is it possible for me. So remember here the size of the array is 4 and the partition I have to do is 3. The subarrays I have to form is 3. So what we are going to do is basically I'm going to check whether is it possible for me to partition an array of size 4 into 3 subarrays such that the sum such that our answer is 7, right? And what is our answer? Like the definition of answer is something which is there, which we have explored and understood it, right? So what will happen? Either it is possible for me to get 7, either it is possible for 7 to satisfy the condition of our question. If it is so, then 7 is our possible answer. But it might be possible that the answers are so since I have to find the minimum, so it might be possible that of these 3 values there exists some other values which satisfy the problem. So what I am trying to say is that it might be possible for 5 also to satisfy the condition. Okay, so in that case, since 5 is less than 7, so 5 will be our answer. Okay, similarly it might be possible for 4 to satisfy our condition. So in that case 4 will be our answer. So what I am trying to say is basically once we get an element which is less than once we get an element which satisfy our solution, which satisfy the condition of the problem, we are going to check the left portion of that subarray. So we can basically I can safely discard the right portion of the this, like I can discard 8 9 10, right? Since 7 is satisfying, so 8 9 10 clearly is greater than 7, so we can safely discard it, right? And I can check on the left portion whether any one of these elements or the minimum, which is the minimum element which is going to satisfy the condition of my problem. Okay, all right. So that the minimum is what we are going to return. Okay, so okay, and how we are going to check whether the element is going to, or whether 7 is satisfying the condition of the problem, we will also see it. But for now, the first concept which we need to understand is basically, let me just write it down. The first concept which we need to understand is our answer basically belongs to the range of minimum to maximum. Okay, and what is this range? This is basically max of array and sum of array. All right, so this is something which we need to understand. Okay, so once we have understood this, now let us look at how we are going to check whether any element from this set is satisfying our solution. Okay, so let us take an example and let us see how we are going to check whether the from the list of probable answer, how we are going to check whether the probable answer is satisfying our condition or not. Okay, so let us take the same example. So here the array is basically 1 2 3 and 4, n is equals to 4, and I'm so sorry, okay, n is equals to 4 and k is equals to 3. Okay, and we also know that our answer will lie in the range of 4 to 10. Okay, so now so here, so basically our answer will be there in the range 4 5 6 7 8 9 and 10. Okay, so let us take the same example. So here, like, array is 1 2 3 4, and our answer is in this range, and we are at our probable answer. So let me write it down. probable answer. So we are investigating whether 7 is a valid answer or not. So right now 7 is our probable answer. If it satisfies our condition, then it becomes a possible answer, and similarly we'll get a list of possible answer and we'll find the minimum of that list. Okay, so let us check. So what will happen is, basically, let us say, and now for 7 I'm going to iterate on this array. Okay, and I'm going to check if ARRI is greater than probable answer. So here in this case is 7. If ARRI is greater than our probable answer, then that is not a probable answer, and we can straight away return false from there, and we can move on for the next probable answer. Okay, in this particular case 1 is not greater than 7, so we are good. Now we will move forward. Now what we are going to do is, basically, we will have two variables with us. One is sum, and initially this is 0. The other is count, which is equals to 0 initially, right? Sum is equals to 0 simply means what is the sum of the subarrays so far. So we will be iterating and we will be storing the sum. We will be calculating the cumulative sum. So the sum so far is something which is there in the sum variable, whereas the count is the number of subarrays or the number of partitioning we have done so far. Okay, so far it is 0, and now we are going to do as sum is equals to sum plus ARRI. After adding the element, I am going to check if sum exceeds 7. Okay, sum exceeds probable answer. What I mean to say is that, let us say, like after adding all the elements, so for instance in this particular case 1 2 3 4, right? After, so till 3 it is just 6, so 6 is not greater than 7, but after adding all the elements 10 becomes greater than 7, right? Now since 10 is greater than 7, then I simply, what I can say is that 1 2 3 is a correct partitioning. So what will happen is that, basically, the subarray will be 1 2 3 and 4. So this is the partitioning. Okay, so that is why if sum is greater than 0, then that simply means I have found a partition, or I have found a subarray whose sum is greater than the probable answer. So I can stop there. I can say that I have found a partition here. Okay, and the sum I will set it to ARRI, right? So why is this? This is basically because after including this 4, right? So 3 plus 2 plus 1 is 6, right? After I have included 10, then the value becomes greater than 7, right? The value becomes greater than the probable answer. So our partitioning is still this position, right? And now the sum is only this 4. That is why we are doing it here, right? So this is something which we are going to do for all the elements of the array. Once I have done that, then I am going to increase my count by just 1. Okay, why I am going to increase my count by 1? That is simply because, let us say, if I have to so basically, if there is just one partition, so this is something we can understand it from a different example. It will be a bit tricky to explain it from this example. So let us say, just for the sake of simplicity, I'm taking an array which k equals to n is equals to 3 and k is equals to let me say it as 2. Let us just say it as 2. Now, or let me just write it down as 3, or yeah, I'm so sorry. Let us say that k is equals to 1. Okay, so what will happen is, basically, so since k is equals to 1, so there is just one partition which is possible here, which is that, basically, a subarray which is equals to the array itself, right? So if you plug this equation or this algorithm in that form, then this particular then the count variable will not increase, right? Since it is just, the entire thing is just one what do you say, the entire thing is just one single shot subarray, right? So in order to accommodate that, we are towards the end, we are increasing the count variable by 1. Okay. Now after doing that, we are going to check if the number of subarrays, right, is less than or equals to k. Okay. Then we are going to return true. Otherwise, we are going to return false. So that's about the explanation, folks. Now let us jump to the coding section in order to code it. So I have already coded it. Now let us look at now let us go through the code. So the first thing is, like, we have to find the range. So the range will be the maximum of r and the sum of all elements, right? So this is the sum of all elements. So the range will be from start to end. Now I'm doing a binary search. Start is less than or equals to end, and I found the mid element. Once I have found the mid element, I'm checking if mid satisfy our condition. If it satisfy our condition, then answer is equals to mid. And I'll check on the left part if there exist other elements which satisfy our condition. If it does, then answer will be that minimum element. Okay. Otherwise, I can safely reject the left portion of the array and I can search it in the right portion of the subarray. Now let us look at this function. So in this function, we started with a sum equals to 0 and count equals to 0 for element in ARR. If element is greater than mid, then in that case we are going to return false. Okay. Otherwise, s, we are computing the sum. If sum is greater than mid, then we have seen a partition and then we are going to increase count by 1, and s equals to element, we are going to reset it. Towards the end, we have increased count by 1. If by the end of all these things count is less than equals to k, I'm going to return true, otherwise false. So that's about the coding part, folks. Now let us submit the solution. So our solution got accepted. Now, so that's about the video, folks. If you have any questions or concern regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.